This is the Stanford Silicon Valley New Japan Project Public Forum Series. And this is the first one of our this fall quarter. Thank you for joining us. We're looking forward to an exciting array of speakers over the next months. So first, and I'm Kenji Kushida. I'm a researcher here at the Shorenstein Asia Pacific Research Center, and I'm the project leader of this Stanford Silicon Valley New Japan project. First, a couple words about the project, and then we'll jump into the talk. So the motivation of this project is that there's heightened interest around the world in Silicon Valley as an innovation system, and the whole ecosystem, not just entrepreneurs and others. And from the Japanese perspective, there's a new wave of startups. If you've been here for a few years, it's very clear now that there's a new wave of startups here. It's a very exciting time. And so understanding what's happening is critical, and then increasing the strength of the linkages between Japan and the ecosystem here is also very important. And innovation and entrepreneurship in general is more important than ever before for economic growth. And in Japan, as those of you that are from Japan know, there's a bit of a, I get a little worried about it, but there's a hype of Silicon Valley. All of a sudden, everywhere in media is about Silicon Valley. But we noticed that a lot of information there isn't necessarily accurate or correct. And that's easy to understand from here. So we should create a platform to send information to Japan about that too. And then interpersonal networks in Silicon Valley. Among the Japanese community or people interested in Japan, that has not been very strong until fairly recently, when more people are here, more entrepreneurs are here, and there's a renewed interest in Silicon Valley. And in Silicon Valley, Japan is actually being reevaluated as experiences in China and other types of opportunities like Internet of Things show that there might be some renewed interest in figuring out how to best make use of the Japanese ecosystem from here. And there definitely needs to be a greater university business ties with Japanese businesses and US universities. For a long time, large companies have sent people to universities, such as here in UC Berkeley, but there's still more to be done in terms of accessing interesting projects and making use of some of the research here in large companies. So the core participants of driving this project is myself and Richard Dasher, who's the director of the US Asia Technology Management Center over in the engineering school, and Takeo Hoshi, who's the director of the Japan program here at Shorenstein APARC. The project components of SVNJ are public forum series with networking, research and publication, policy analysis and implementation, and study groups that we conduct with places like UC Berkeley, the European Commission, and Keio University. Our efforts are supported by sponsors of various levels. We'd like to thank them for our activities. Diamond sponsor, Kozo Keikaku Engineering, Platinum sponsor, Komatsu, Gold sponsor, Will, and several silver level sponsors, NEDO, ANA, MUFG, Nomura Research Institute, Omron, Startia, and Rakuten. Thank you for your support. And we have a couple strategic partners, IGPI and Ishin. So that's enough about the project now. Let's jump into today's talk. I apologize in advance because I speak very quickly, but there's a lot to get through. And so these slides will be available on the website later. And today's topic is critical because we're at the cusp of a major shift in how production occurs at large companies, small companies, how we think about production. We call it the ICT-Enabled Services Transformation, and it's the race to avoid commoditization. So the core question for firms everywhere is how to avoid commoditization in a global digital world. A commoditized commodity is an offering that's differentiated primarily on the basis of price rather than value added. There's little opportunity for rent above costs. So a preview of the main points that we will cover today. First, firms are turning to services to escape commoditization. Second, services as activities are transformed with IT tools, and this whole process is driven by what we call the algorithmic revolution. Third, services themselves can be commoditized. Escape from commoditization to move to services, but then services can be commoditized. And this is accelerated by the advent of cloud computing. And we'll talk a little bit later about what we mean by cloud computing. So the search for value will revolve around orchestrating combinations of commoditized activities and components. That's where we're headed. So there are two parts in today's talk. The first part is the ICT-enabled services transformation, and the second part is cloud computing. from scarcity to abundance. The core research team for this set of efforts, because this is based on a series of research papers that have been published and some that are underway, is John Zeisman, who is at UC Berkeley, myself, Stu Feldman, who is a former VP of Engineering at Google, and before that he was a VP at IBM, Jonathan Murray, who is currently the CTO of the New York Times, former CTO and Executive VP of Warner Music, formerly Worldwide Public Sector CTO of Microsoft, and Niels Christian Nielsen, who is on various boards of exciting companies and research institutes in Denmark. So whenever academics say, here's what's happening in the world, a good question is, well, why do you know anything about the real world? Because you're an academic. And our answer here is, well, we work with people who are at the forefront and the frontier of much of the transformation that's happening. So the ICT-Enabled Services Transformation, part one. So the global transformation of value, how to create value that's underway, needs to start from understanding how services are being transformed, particularly by IT tools. That's the key. So in order to understand that, to bring it up to services, we're going to start through a history of production. First is the evolution of manufacturing and then services. First, we'll start with manufacturing. The evolution of 20th century manufacturing. The early 20th century saw the emergence of mass production and mass markets. For example, the Model T Ford. Right? So the rise of the US as an industrial power. This happened in the early 20th century. In the post-war period, lean production and diversified quality production were new production paradigms that are emerged from, say, the Toyota system in Japan that led to the rise of Japanese manufacturing and certain European areas. And then in the 1990s and 2000s, modularization, supply chains, and outsourcing. Right? There was an American comeback as design stayed here and production was outsourced, global production networks were orchestrated, and supply chains and then processes were outsourced. So this enabled, in some ways, the rise of South Korea, Taiwan, China, and parts of India as the production system here shifted. So what all this caused was accelerating commoditization. Right? And that's what, if you're from a company and you're working at a company, now that's the challenge. Right? Everything is becoming commoditized at a faster rate than ever before. So then firms recently have been turning to services to escape the commoditization that's seen in manufacturing. So for example, IBM, that almost went under in the 1990s, so they radically shifted towards services. Right? They shed maybe 40% of their employees, bought the consulting firm, and then instead of offering mainframe computers as an item, a good that they're selling, they offered services and embedded their equipment in that. And major service components are being offered by diverse firms, including HP, GM, GE, Schlessenberger, Waste Management, PG&E, and Caterpillar, where they say, okay, we're not just selling you a product, we're selling you a service. And outsourced manufacturing like Dell, Cisco, and Nike. This was a major transformation where, say in Silicon Valley, there used to be an Adidas factory and Fila factory and things like that, and all of that is now outsourced. So that's how and this is a familiar story to most of us, manufacturing, and then there was a commoditization and then a shift towards services. So then how did services evolve? It's a separate thread that meet right about now. 20th century services, there were 5 major broad drivers of service growth. The first was developmental shifts from economies away from agriculture and resource extraction and manufacturing. And then the second, rising incomes lead to greater demand for services. Right? Once you have a car and a house and a refrigerator, then next you want to take a vacation, you want a massage, things like that. So that's another, rising incomes always lead to greater demand for services. A third one is an actually accounting error from the rise of outsourcing. There's a great example of a GM factory that has a window washer. The window washer does the same thing, except all of a sudden GM decides to shift from providing the window washing service in-house to buying that service from another company. It's outsourced. But actually it's the same guy doing the same job. But all of a sudden that function becomes part of the services bucket of accounting. So some of the rise in services, as we see the rise in services, is just the same jobs being done by same people but under different corporate boundaries. So there's some of that accounting error. That's the rise of outsourcing. And then there's been the over the last century, expansion of government role in society, things like social security, unemployment benefits, things like that. And then increased female participation in the workforce. A lot of functions that used to be undertaken in the house, child raising, cooking, and things like this, as female participation in the workforce has increased, it's led to markets such as daycare, eating out, and an array of other services. So see, these are some of the 5 main broad drivers over the last century of services growth. But what we're not talking about here, when we talk about the ICT-enabled services transformation, is not the so-called services economy that most people look at. It's not simply the rise of service sectors as a proportion of the economy. And it's not simply innovations in existing service activities. Because there are fundamental problems in defining services in the first place, right? Until very recently, economic estimates of the services sector in the economy, proportion of it was everything that's not manufacturing and not mining, not agriculture. So it was the residual. And it's very hard to analyze things that are basically a residual, where you don't know what it is and you're just calling it a residual. So there have been fundamental problems with defining services in the first place, but then what the numbers hide is a real transformation of activities. And that's what we need to focus on. So the services transformation is driven by what we call the algorithmic revolution. When activities are formalized and codified, they become computable. And processes that have clearly defined rules for execution then can be unbundled, recombined, and automated. So these are activities transforming once we can express them with algorithms. So the codification of services allows for the rapid replication, analysis, recombination, customization, and creation of new services. And the algorithmic revolution is driven in turn by the vast increase in computing power, storage capacities, and connectivity at ever lower prices. You're probably familiar with Moore's law, where it's a general principle laid out where processing power tends to increase by double every, is it 3 years? Yeah. And that law has held pretty much. It's been the benchmark for the semiconductor industry in creating the next generations of chips. So the radical increase of processing power, and when I speak to Japanese audiences, it's always fun when I point out that the Apollo mission that took the rocket that took the people to the moon, the processing power of that, the core processor was less powerful than the 1984 original Nintendo Famicom, right? So that's the level of processing power to get somebody on the moon. Now that is much less powerful than whatever processor might be in your shoe if it takes data, right? And then let alone your smartphone. So the degree to which processing power has increased in capacity and lowered in price is truly mind-boggling, and we'll talk later about cloud computing, which takes it to the next level. So from processing individual tasks to connecting vast range of services systems after the activities are transformed with IT tools, that's the world we're in. We're still talking very abstractly, and so we'll have some concrete examples. But before that, the point is that classically, some very classic economics conceptions of services considered it an economic black hole, because in the economy, you have manufacturing and you have services. Manufacturing productivity was increased dramatically with the Industrial Revolution, but services productivity was not increasing very quickly. It would take somebody to drive from point A to point B almost the same amount of time to drive from point A to point B. A haircutter, their productivity doesn't increase that much. We're not using machines to cut 3 people at once with one person. And the classic example was a Mozart quintet. It takes 5 people the same amount of time to play the same amount. So, and in the numbers it was showing up that in services there was a lack of productivity. So then the hypothesis was what's going to happen is as the manufacturing part of productivity increases and services doesn't increase, then more and more people are engaged in non-productivity increasing services activities. And that's going to lead to a decline of economic growth overall. And it was called Ballmann's disease, Ballmann's dilemma. Limits on service productivity. However, now, more recently, services has been the productivity driver. If we look at the economic indicators, it's clear that the source of productivity in the fast-growing areas, say the US and the faster-growing parts of Europe and parts of Asia, is actually from services. So the way we conceive it is Moore's law has solved Baumann's dilemma. So the critical point here is that the capacity to develop and deploy innovative ICT-enabled services throughout the economy is central to the growth, right? So services which were once not growing much now can be grown. So then how do you do that? And a key lesson from previous scholarship on the first, what we could call the IT revolution, was actually a process of large firms taking calculators that then became computers to do fairly simple computational tasks, but then discovering that there was an array of new things they could do with it. For example, airlines took computers to manage the reservations. But then they realized, okay, we have all this data on reservations. We can actually change the logic of when airplanes are flying from where. So it changed the complete supply-demand calculations for what they would do and how they would operate their pricing. So then that was a perfect example of installing it for one set of things, but discovering that it could be applied for a different set of things. That's the first round of productivity increases that we saw from the implementation of IT. We're at the cusp of a next round of that, where we look at large corporate users of IT and figuring out how they are transforming usages of IT. And this revolves around services. So IT-enabled services are becoming the center of how firms organize themselves and compete, and what does this world look like? So first, there are several patterns here. First, the businesses are turning to IT services embedded in products to escape commoditization. Right? So some nice examples from Komatsu, for example, is they use sensors to, and previously GPS sensors. So if the excavation machine is about to, the operator is about to make the excavation machine do something like dig a little bit too far, it can stop automatically. So then you need a less skilled person that may not do that each time and notice that they're going to do that. The machine helps them. Apple, of course, the products are embedded in services in terms of the original iPod or your smartphone. As a piece of equipment, it's okay, but there's no point if it's not embedded in the iTunes store or has the App Store of apps available to it. So when the iPod first appeared, most Japanese manufacturers said, well, it's not such an impressive piece of equipment. We could make something similar and make it look better. But actually, it was the connection to the embeddedness into the iTunes store that made it critical. And that's how the first round of smartphones people missed, too. Otherwise, if it weren't for the configurability of the iPhone or the Android handsets themselves, because they were embedded in effective stores, app stores, then it's basically a nice touchscreen phone that doesn't work so well as a phone. It's the service execution that was the point. And it swept away whatever came before it. And it's the driver behind things like Under Armour, which was high-end exercise clothing and whatnot, spending almost $1 billion on sensor network firm to buy it, to try to figure out how they can embed ICT-enabled services in their products to escape commoditization. And of course, there are more failures than successes. Sony has had an array of products that were chasing and doing something similar to what say Apple products were able to do, but the services execution part really suffered and they were not able to. And Nokia, that dominated with, say, up to 60% of global handset shares, tried to shift towards services, but they weren't successful in their implementation, and now the handset division got purchased by Microsoft. So second pattern is firms are transforming products into services, and the services are often delivered or controlled through ICT networks. For example, software used to be products because they used to be physical CDs. That shifted to web delivery. Other than lowering pirating and enabled a new software as a service deployment model that allows constant upgrades, this has a major shift in how we consider software. It's no longer software products, it's software services. Once it's a service, then its function can be shifted significantly. And repackaging, right? So GE used to sell refrigerators. Now they sell refrigeration services that can customize around what you need to do. Or Kone Cranes, the Finnish crane company that operates the heavy equipment around ports. They used to sell cranes. Now they sell elevation services. And so products are being embedded into services. The third pattern is that products can become portals to service, or if they're successful, platforms for services. The iPod, iTunes, and iPhone App Store are the classic examples. Amazon Kindle versus Japanese antecedents. Say the Sony Reader was a far better piece of equipment than the original Amazon Kindle, which was a bulky, low-performance, aesthetically unpleasing piece of equipment that a lot of Japanese manufacturers first laughed at, but it was the array of Amazon books available on the Kindle that then led the Kindle to take over much of the electronic reader market. And becoming a platform is difficult, right? Everybody wants to become a platform, but in Silicon Valley too, there's a graveyard full of operating systems that tried to become platforms and weren't able to. So MeeGo is actually Nokia's, HP's WebOS, BlackBerry, and Windows Phone. All tried to, but have failed to become platforms. And then, of course, gateway products that are portals to services can be commoditized as well. So the Android operating system actually rapidly commoditized Samsung and HTC's offerings of smartphones, because it's not the phone that matters as much as what you want to access through the operating system. So, and the very characteristic pattern is that traditional boundaries between sectors are becoming blurred. Right? If you look at say a McKinsey analysis of sectors from 20 years ago, there's this sector and that sector and this sector, and there are distinct firms in each sector, and they're doing different things. There are different dynamics of competition. Now they're all melded together. Digitization is bringing previously, even physically distinct product and sectors together. So previously distinct players that are now in competition include, right, Nokia, Sony Ericsson, Motorola used to make mobile phones. They're all smartphones. PDAs, personal digital assistants, Palm, which was then purchased by HP, was a dominant market leader in the US. Digital cameras by Canon, Nikon, Sony, Kodak, Olympus, Fujifilm, they were in there. And digital video cameras, kids these days, I don't think they even know what it is. Sony, Panasonic, JVC, they used to do that. Now it's all been eaten. And Nintendo, Sony, portable gaming, they were all disrupted by smartphones. Right? And so other areas, such as the advent of Tesla, might be considered the challenge to the auto industry, but actually a bigger challenge might be Uber, right? Where people who are living in urban environments, they don't buy a car, or they sell their car, not because they can go to an electric car, but because they can use Uber. And so in that sense, the automakers looking at other automakers are suddenly being disrupted by a services company. So a typology of services, it's a useful way to think. All this stuff is transforming with services. How do we sort through and think about it? Three kinds. Completely automated services, where if you apply an algorithm, it becomes completely automated. That's on one end. On the other end is something that's irreducible and has to be augmented. So let's say a massage person or a hair cutter. These people can increase their efficiency a bit, such as booking and whatnot. But in their essence, it actually requires a person to perform a task for a certain amount of time. That's much less productivity increase potential for them. So then most of economic activity happens in this middle space, the hybrid. Completely automatable, irreducible, so it's therefore human augmented, and then hybrid. So hybrid systems of integrating systems of people and machines, this is where a lot of the world is heading. And while automated services is the focus of things like, say, Google, social networks, and a lot of finance and communications areas, it's these hybrid services where we have large companies performing all sorts of tasks where do you implement IT to enhance people? When do you use IT to replace people? How do you manage an organization that can take and combine all of the pieces? Because automating routine business practices, say mid-level accountants that used to be everywhere, now you don't need mid-level accountants because it's all done fairly automatically in software. So, but everybody's doing that. So automating routine business process must be done, but it only gives you a temporary advantage because everybody else is doing it. So then, of course, continuous innovation does remain central. And enduring advantage is created by the reconceptualization and reconfiguration of services. Which tasks do you split apart and move around? Which people do you replace with IT systems? And which IT systems do you use to augment people? How do you put them together? And so the value there is captured by strategy and the organization of the firm that can handle this kind of thing most effectively. Because the services dilemma, of course, is the objective is to create distinctive offerings for customers. So, because if you're dependent on people alone, then there are limited productivity gains, but then you can actually offer customized things to everybody. But if you're dependent on ICT alone, unless you've made it highly customizable, then a new form of commoditization emerges where everybody else uses the same ICT and then can do the same things. So where's your advantage in that? So what are the roads to services? Do you build or destroy? Do you augment human capabilities or replace them? Do you rest on your technology laurels or innovate continuously? If you rest back, everybody will overtake you. So how do you innovate continuously? Well, a step before a few recommendations we have is we must recognize that IT services are now systems that are built, they're capital intensive, and the latent capacity actually acts as inventory. Services used to mean something like, it's something that you consume the moment I create it, right? A service is a transfer like that. But now services are actually systems. If you think about Google, they have massive, massive capital expenditures for their data centers, billion-dollar data centers, several of these. If they're not being fully utilized, then that's basically inventory. It's latent capacity. So even though we're talking about services, it looks very much like manufacturing style production. So we need a new set of languages to talk about this. So 4 principles in moving towards ICT-enabled services. Well, implementation and innovation is a continuous process. You have to automate the routine, but at the same time as automating the routine, you have to innovate and discover. There's an interesting poll of US C-level executives and Japanese executives on how they view IT as an example of different worldviews. The Japanese executives tended to see IT overwhelmingly as reducing costs, increase efficiency, a cost-cutting measure. And C-level executives in a lot of US firms overwhelmingly saw IT as creating new business opportunities, creating new strategies. So is it a tool for offense or is it for just defense? Well, what kind of organizations do you need? If your organization doesn't have a strong CTO that can have a strategy, it might be difficult to innovate and discover based on IT tools. So ICT tools create possibilities. Judgment and human talent are needed for their effective use. And one danger is that decomposing and recomposing too rapidly can lead to destroying the organizational capability. There are a variety of cases that I don't need to go into now of firms that overzealously said, well, we can outsource this, outsource that, outsource this, take away that, automate this, and each time their stock gets a little bit of boost in the market. But actually, when they try to put that all together, then it really doesn't work, and their overall delivery of quality declines fairly dramatically. And so aligning ICT and business strategy. Is it just to support the CFO in terms of cost cutting or support new strategies, and who's responsible for that? So now let's shift gears a little bit. That's the ICT-enabled services transformation. Activities are transforming by applying IT to it. And they're transforming in a variety of ways from automated to irreducible to hybrid. So figuring out where you are on that and which tasks you want to go on each of those. That's the critical challenge, and then how to get there. Part 2 is a little bit more about the tools that are available. And this is actually a fundamentally new computing paradigm that we're in. And we're arguing that we're on the very cusp of a major, major revolution in how to think about how organizations can make use of computation and processing power. So the bottom line here is that throughout the course of human civilization, information has been a scarce resource. Stone tablets, scrolls, handwritten Bibles and whatnot. And there was a big revolution when Gutenberg, printing press, right? Then it was stored information became much more commoditized. Well, and then computers. The history of computing has shifted from one where a computer costs multi-million dollars and it's the size of this building to tiny little computers that can have so much processing power that's so cheap. What that's driving is a fundamental shift from computing power being a scarce resource to an abundant resource. For the first time now, we're seeing marginal cost of 0 for increasing computing power. Even Amazon, for example, even their consumer offering at this point for what was it, $90 or so, you can have unlimited storage. And so marginal cost really is zero. And for corporate applications with much higher demands for reliability and performance, the marginal cost is rapidly approaching zero. So if each additional piece of computing power costs almost zero, then everything that used to be high-end and not commoditized was optimizing for scarce resources. But if you don't need to optimize for scarce resources because there's an abundance of resources, you can essentially just throw a lot of processing power at a problem and use commoditized components, commoditized hardware, commoditized databases, commoditized networking assets, and then throw all that in to attain at much lower cost what used to be high price point, high-end offerings. So that's the fundamental shift. And cloud computing, which is a new paradigm, is allowing that. And that's what's driving the ability to analyze data in much bigger ways than ever before, and it accelerates the services transformation. Because the shift towards cloud computing, we're arguing, is as transformative as the shift from mainframes to PCs, clearly becoming ubiquitous. A third of internet users in the world today visit websites built on Amazon Web Services. And Dropbox, its scaling was incredible, right? In 2007, it was founded. 5 years later, it had 100 million users, and that quadrupled in 3 years. They don't own their own hardware, right? They build all of that on top of Amazon Web Services and others. They procure the storage capacity from elsewhere. Say the initial social networking service that got people's attention was Friendster, which predated MySpace, which predated Facebook. They ran into the classic problem around 2002 or so, where the more users they got, the more processing capability they required, but they weren't able to add capacity as quickly because there was no option to get it from outside cheaply. They had to build their own. So they fell into the trap of the more users they got, the worse the service became, until it became basically unusable and people left. This doesn't happen at all at this point. And Netflix, that delivers streaming video, doesn't own its own data centers. And for example, Google, UC Berkeley fairly recently shifted over their entire email system to Google after their own internally built system crashed because they couldn't handle the volume anymore. And it's a critical infrastructure for small, medium enterprises, and Microsoft's biggest revenue source at this point is enterprises. Cloud is not simply the internet. Marketing hype, and some of it done on purpose, says that, well, here's a cloud-based solution. This is even sounding a little old because now it needs to be an Internet of Things solution or something like that, where you can't sell anything if it's not labeled cloud. But actually, we mean a very specific thing. Because the internet is a decentralized network of networks. Right? It was originally built by DARPA so that if the part of the US was under nuclear attack, regular telephone lines don't work because they're centralized. If you take out a couple nodes, the whole network goes down. But DARPA's network was able to be decentralized so that even if part of the network went out, it would be fine. That's basically, it's a decentralized network of networks. That's the internet. Cloud is the opposite. It's global scale cloud providers with large, at this point, billion-dollar caliber data centers that are very centralized, and there are only a few global scale actors, Google, Microsoft, and Amazon, that can offer scale that's so big that the marginal cost is close to zero. Right? These are the scale that we're talking about. So it's not just the internet. Cloud alters how we use, store, and process information. It also raises a variety of policy issues surrounding information, like privacy, security, sovereignty, who owns the data, jurisdiction, whose legal system is applicable to, say, a Google data center that has data from a different country. How does that work? It's still being figured out. Government policy will inevitably shape how cloud services spread around the world, which will in turn matter because that's the underlying fabric for innovation and tools, as we see. The big picture that I started to talk about was whenever the underlying industrial production system changes, political interests and actors are reconfigured. Right? From wood to coal, or from steam power to electricity, or telegraphs to telephones, or mainframes. These were major shifts. When wood went to coal, for example, well, where was the coal? A lot of it was in northern England. And once coal became a viable source and an abundant source of energy, that area experienced the Industrial Revolution first. When oil replaced coal, then a lot of oil was in the Middle East, and that shifted geopolitics to a configuration that leads up to today. Computing power is shifting from being fairly decentralized to being quite centralized in these global cloud firms. So what are the implications of that? Because different countries react very differently, and there are international ramifications of major production system shifts. For example, when the US railroads were completed, cheap wheat from the Midwest was able to reach the Atlantic coast very easily and cheaply and quickly. Therefore, in Europe, all this cheap grain started pouring in. But different European countries reacted differently, leading to very different results by being hit with this cheap grain. For example, England was wide open, free trade they believed in, and their agriculture took a tremendous hit. It left a lot of people streaming from the countryside to the cities, who then became factory workers that helped fuel the Industrial Revolution. Germany, this led to the alliance between iron and rye, which led to the support base of Bismarck, and we know what happened after that. France raised tariffs, and Denmark's reaction was very interesting. They said, well, there's all this cheap grain coming. We can't compete in our agricultural sector. Let's just take that cheap grain, feed it to cows, and become high-end dairy farmers. And dairy a lot of high-end dairy in Europe still is from Denmark. So the point here is that as computing power becomes a very abundant resource that can pour into any organization doing anything, what's the way to adjust that will lead you more to a Denmark strategy rather than getting washed away or trying to block it or ending up in a strange organizational tension inside the company that leads to unfortunate results, or just trying to block it. So how do we get to the Denmark strategy in this? That's the international ramification of this. And so one of the efforts that we've done is to capture the political economy analysis. We need to build an understanding of the industry, and we have a few frameworks of that in some papers that we've published. We don't need to go too far in depth, but just to be clear, what is cloud computing? Because there's a lot of confusion, a lot of it intentional. It can't simply be everything online, because whenever a definition includes everything and excludes nothing, the definition itself means nothing, right? So what is cloud computing? Cloud computing delivers computing services, which is data storage, computation, and networking, to users at the time, to the location, and the quantity they wish to consume, with costs based only on the resources used. So we almost have a utility type of conception here. So users procure the amount of computing they want without investing in their own infrastructure. The illusion of infinite resources on demand is available to users. For example, if Chevron puts its, 200,000 employees, put them on Gmail, Gmail doesn't say, oh, sorry, the rest of you, we have to upgrade our systems because we're a little over capacity. No, it's the illusion of infinite resources. Applications allocate the compute, memory, and storage resources without reference to the underlying physical infrastructures. If you're using Microsoft Office 365, it doesn't say, oh, hold on, we need to reconfigure because we just built a new data center in the Nevada desert. It doesn't work like that. It's transparent, and it transforms computing from an organizational standpoint from a capital expense to an operational expense. You're buying services rather than buying equipment. And that can actually, depending on how your company is configured, cause various problems, or it can be an opportunity. So characteristics: providers can dynamically add, remove, or modify hardware resources without configuring the services that depend on them. And from the user's vantage, it's essentially utility. You just want to buy this amount of processing power, you pay for it, and then it's yours to use, and then you're done. That's it. So you don't have to, And only a handful of firms are able to offer truly global scale cloud infrastructure, because how many companies out there can invest in multiple billion-plus-dollar data centers very easily? Not many can do that, and not many have. And these are the firms that have. So what's new and significant about it? Because a lot of the underpinnings of cloud, well, virtualization or having remote access to computing resources, it's not new. Our point is that it's rapidly becoming an innovation ecosystem, a production environment, and a global marketplace all at once. It's unique in both being the production environment and the market platform for innovators. And the platform has global reach. In other words, as an innovation ecosystem, right, entry barriers are lowered. No VC is going to pay for somebody to build their own data center unless it's a very specialized data center. And the point is the ability to rapidly scale up, like Dropbox, and rapidly scale down. You can build all this infrastructure, and in the previous paradigm, if nobody used what you needed, then you're stuck with all this infrastructure. Well, now, if you experiment with a service, it works well, great, and if it doesn't work well, fine. You just shut it down, and you're not paying for what you're not using. And for enterprises, this allows a potential because a lot of R&D operations within large enterprises used to follow the process of, well, I'd like to try to do something with this amount of computing power. Okay, fine, we need that allocation from over here, or you can only use this much because that's being used for that. So you can't run the experiments at the scale you want to. Now you can just procure resources from the outside. And it's not just raw production as the input. It's also the tools. So I have a friend, for example, who built a company analyzing a person's genome. But it takes about 1 terabyte of data to analyze a person's DNA if you break it down. And if you're analyzing several 100 million people, that's a lot of data. The fundamental math is different. And his company sold those as tools. The data was located in Google, and Google or others could provide the processing power. So you actually have access to these very powerful tools as a user. You don't have to build anywhere near as much as you used to. And these tools are available anywhere where you have basically an internet connection. So the tools available are fundamentally different and more powerful than ever before. And so services and tools are essentially, there are all these building blocks available that you can make things from. And a global marketplace, right? So major software evolution used to transpire. It used to entail trying to find local marketing partners, local sales partners to try to take something international. Now it's completely global with much more ease than ever before, which leads to new discoveries where people realize that people that are not intended users are using whatever service for uses that are not intended. And that can become a next place to shift to. So the effect of cloud is that it massively accelerates the commoditization of computing resources. And this is about to hit Silicon Valley very hard because it disrupts incumbent computing resource providers. This is already starting to happen. High-end servers from Intel, or high-end servers from HP, or high-end routers from Cisco, high-end processors from Intel. Why would you buy a couple very expensive high-end things that are optimized for scarce resource processing power when you can get equivalent or better performance with a large number of very, very cheap machines? Why don't you? Well, people are starting to realize, well, why not? It's just legacy systems within large companies that need to be wiped away and rebuilt, and some of them are starting to rebuild. And that's a huge threat to them. And even cloud computing, right? The cloud data centers are not using these folks. And so therefore they're being left out of the proportion of processing tasks that people used to do based on these. Now the cloud data centers are not using them, so they're being left out and rapidly commoditized. How do they go to the high end? And nobody has a very good answer yet. And so they're having trouble. And databases, the Oracle financial management system or Oracle databases all have management logic in there. They're not complete open databases where the API allows you to control everything from outside, from the platform. There's some management logic in there. Why is there management logic in there? Because they're optimized for scarce resources. Now it doesn't need to be optimized like that. And then large system integrators. Enterprise solutions and medium enterprises was all about putting parts together to create a customized solution. Why does it have to be customized? Well, because you have scarce resources. Now, if you have abundant resources, it doesn't have to be high-end customization where the cost is. You can customize things much more easily. So then for users, it opens up major potential, and the challenge is how to use it as a strategic advantage. So we'll skip some of these. There's some papers that you can read. There's some implications with some of the buzzwords that are flowing around here that have real implications, but they're often used too much as marketing hype. This is what we're talking about, right? Because big data and Internet of Things are everything. Well, a lot of this circles around what types of data and what types of analytics then are therefore useful for what. And if you ever encounter things that aren't very clear about this aspect of what it's offering, then you know there might be a problem. Because there's some interesting studies out there. So the myth of big data is that there's all this data being produced by people doing all sorts of things. You can grab a huge chunk of messy data and somehow extract data that is exactly what you need that will provide the magic bullet for whatever problem you're looking for. But we're actually pretty far from there, where even in Google, there was an interesting confession paper from Google saying that, look, Google flu, which tried to predict the epidemic, the flu, this year's sort of flu, how it spread based on a variety of search terms. And they were very sophisticated about how they tried to do this and tried to predict the Google flu. Well, the first year it completely overestimated the actual flu. The second year it completely underestimated it. And the third year they were still way off, so then they canceled the project. And some of the things they discovered was, for example, right, if you're very low income and your son or child has or daughter has a flu-like symptoms, you're not going to search on Google, right? On other areas, if the news said there's a terrible pandemic, then depends on which news you're watching. Then you say, oh, there is a terrible, oh, is this a flu? So it was capturing all sorts of other behavior and not the actual spread of flu. So a nice label was all this digital exhaust that people are producing in all their activities probably isn't useful yet, anyway, to analyze things that are not optimized. So collecting the data that's relevant to what exactly you want to do with it, that's actually still very, very important. And that's where the potential of sensor networks with IoT, Internet of Things, comes in. Because basically sensors are very cheap now. They're so cheap and processing power is so cheap. So it used to be an issue of, well, I'd like to gather this data, well, it's too expensive. That's why you're going to try to have a proxy for that data with something else. Well, now you can go ahead and put sensors in imaginative ways. And the upper bound of what you can measure is not cost, it's your imagination. And so yeah, for example, modular systems, how do you adapt, are useful for this? So let's say you have ATMs. Let's say you have a lot of ATMs, then you're wondering what kind of system to build for an ATM. Well, maybe it makes sense as an automatic teller machine. Well, if you have unexpected data streams from, let's say, little scanners that can read what type of germs are on the physical paper that goes in the ATM, that's a data stream that might be useful if you put ATMs in places, let's say, that are in developing countries where people do use cash, and there are a fair number of ATMs, cash for tax reasons and whatnot. Well, what if you try to read that data of what type of pandemic is spreading if, say, avian flu or something hits? Let's say parts of China, you do that, and then get the data stream, and then the ATM could actually be producing this data stream of the germs that are available on the paper money that people put into it. That's a data stream that's very cheap to do that now. Oh, why not? Measuring pollution based on not stationary things, but taxis, right? Little cheap sensors that you put on taxis. Then you can use the physics of fluid dynamics rather than Newtonian physics to try to figure out the patterns of how these things flow. That can be done. We have the tools to do it. Sensors are cheap. That's the type of Internet of Things that are useful, where and that does lead to how to think value co-creation with your customers and your suppliers. Because if you're trying to do something with your suppliers, then maybe you want to measure areas of things that your suppliers are doing that you'd like to know about, but you had no way of knowing about before, or how your customers are using whatever you're giving them, you're selling them. And so large-scale sensor networks with analytics, as computing power prices decrease, so much more can be done. And we're at the cusp of people experimenting with this. This raises some policy issues, and everybody's talking about these, but there are still no very good solutions. Data privacy. privacy is about who is allowed access to which data. Security is about how to protect data from unauthorized access or manipulation. Data sovereignty or jurisdiction, who owns what data. Interoperability, the terms under which cloud users can interact with multiple providers, because some places will want to make rules where you have to be able to prevent lock-in to a single provider. Reliability, the expected of percentage without downtime. Legal responsibility if there is much more downtime. And another set of policy issues is national government concerns. There are norms of free trade and open access. But at the same time, most countries do like a level of national control over their innovation and production. So everybody has classified research projects. Well, what if you need these cloud tools and cloud resources that are provided by 3 major US-based multinational carriers to produce very high-level innovation that's critical to your economy? Almost all countries become users, not producers, of the resources. So do you really want your critical infrastructure for innovation to become dominated by these US carriers? It's a real question, because the dilemma is if you don't use them, you can be left behind very, very severely. If you do use them, then you're dependent on US-provided infrastructure. Are you sure that's what you want? And so national industrial policy, what can governments do to help? And the easiest thing that people like to point to if you're a politician is build a data center and say, look, we built that, there's new employment, except the data center probably doesn't do very much, it doesn't employ many people, and it's hopelessly out of date. So what do you want to say? Nobody gets credit for saying, well, actually, we're building capabilities to use all these tools, to use these cloud resources in new ways. But that's the direction that industrial policy probably needs to go. Traditional issues are reopened, right? So the traditional collision of US and European privacy rules. And where does Asia fit in all of this? Because these issues are reopened with cloud. And for example, new issues that become quite acute for a lot of applications is that requirements of the US Patriot Act. The US government can demand any data passing through the US and from all multinationals with a presence in the US. So Patriot Act free is actually a national carrier strategy. Deutsche Telekom was advertising this, saying, well, you put your data on our servers, and actually it's more expensive, but then actually that makes it free from US government. The US government cannot say, well, maybe there's a terrorist that you were affiliated with somewhere else or was using your system, therefore we're going to go and take your data, even though you're a German company. In Germany, you are using Microsoft servers. Something like that is what the national carrier strategies can do to avoid that. That being said, then there's a market for which company tasks do you use for probably higher cost but locally based cloud providers and the global scale ones that can be much more powerful and low cost. And where does China fit for all of this? And of course, there are always multiple levels of policymaking that start to get very messy, an interplay of international organizations and EU-type regional governments, the national governments, and the domestic politics of each place that move and influence each country's behavior to all of this. All of this is emerging, and so it'll be fascinating to see how it unfolds. And so cloud providers and telecommunications regulation. I think by this point, the most recent data, Google was at least #2 in the amount of data that was carried over physical networks that it owned, more than AT&T or Verizon or the other carriers, NTT and all of these. But is Google a telecom carrier? It would say absolutely not. It doesn't want to provide universal service and all of this. So, but depending on how telecommunications is regulated, where do cloud providers fit? And national or national scale carriers are, telecom firms are usually politically very powerful. So that's what this debate over network neutrality was all about, right? They're the Silicon Valley firms that are users of a lot of the networks that are provided by telcos. Telcos wanted to charge different prices for different user firms, and it became a whole issue of access. So could they just make preferential treatment for their own services versus others? And this issue has been reopened a number of times, but it's likely to transpire differently in different countries around the world. And antitrust, how big is too big? If Google ends up being any bigger than it is now, is it going to start to get pressure to be broken apart. And this is starting much quicker, much earlier in the EU, and US will see how things happen. So just as a quick wrap up, so that we have a few minutes for questions and answers. So services transformation and an era of computing abundance. Cloud will be the baseline for efficiency and processing power to accelerate the services transformation. Government policy will inherently shape services in each country and region, and particularly cloud, but more broadly so, because services is all about information. The search for value in services from big data and the Internet of Everything in an era of computing abundance, well, that leads to the point that cloud is critical to gather processes and deliver information. So who has the platforms and the analytic capabilities? And who is best able to use the analytic capabilities? What kinds of education systems are you going to put together to build systems or to use systems more effectively? Do you want to be the Denmark of that? Probably most places do. So if you're more interested in this, we ran through a large number of papers, the main points that we gave. So these are all available online on our website and other places. These have been published. And so some work on the services transformation, some on cloud computing. And there are more papers that are newer underway, and it can be found at the Stanford Silicon Valley New Japan website. So thank you for now, and we have a few minutes for Q&A. That was a lot. That was 3 different talks in one. So. So our speaker series will have a combination of entrepreneurs who are doing interesting things here, and academics who are studying very interesting things related to Silicon Valley. And so the point of this one was to provide a big picture view of some of the ways that we're rethinking how fundamental economic activities are being undertaken. So figured we'd open with the big picture and then have a lot of narrow interest. Well, if there are no questions, I think there's more food still outside, and it's still light outside, so please spend a few minutes to, oh, okay. Yeah.
So thank you for your presentation. My question is the transition of the business model of the cloud players. I mean, the Google or Facebook is the main sales of them is advertisement. So the cloud business is, you mentioned, is really needs a lot of money to make the data centers or something like that. So the new cloud players need a huge database system or new data set. Maybe it can borrow from the Amazon or Google. So the new business player on the cloud making cloud service, the business model of the new players is totally different from the existing cloud player like Google, Facebook,
So business models of cloud players. Well, interestingly enough, I have a few extra slides here. So there are applications, and there's a platform layer, and there's infrastructure, right? And so, for example, applications are these applications. A platform can be the operating system, et cetera, and the infrastructure used to be that in the PC model. And in the cloud ecosystem, there are 3 different types of cloud providers. There's the cloud providers, there's the network providers, and the device providers, right? 3 different kinds of providers. And where are they going? Right, if in the cloud domain, there's software as a service, platform as a service, infrastructure as a service, and network providers. This is like AT&T and Verizon or NTT. They offer network services and infrastructure, and device providers. They have these layers in them. So the 3 competitive battles for firms involved in the cloud ecosystem, there's the device wars. Who's going to win in the device? And this has produced more dead bodies than winners, and it's a duopoly at this point. Right? So Apple and Google Android, but then Nokia, Microsoft Windows Phone hasn't worked out, HP WebOS, all of this didn't work out. That's the device part. Winning the user, how do you get, to make a platform, you need people making apps. How do you win them over? And then the search for network value. What's the point of AT&T or NTT? What can they offer beyond just commodity pipes? Everybody else would like them just to be low-cost pipes, but they're trying to figure out why to live. So this is how the battles undertake. The device wars are here, the search for network value here, and winning the user are there. These are the cloud firms like Amazon, Google, and Microsoft. And if you look, everybody is going towards the platform layer. This is Amazon. They started providing infrastructure, and then they went towards the platform layer. And then Microsoft started with the PC era paradigm, but then they went towards the platform layer. And then they go to the platform layer, and then they offer devices, right? Amazon first provided virtual machines, then they went towards trying to offer devices. Microsoft, same thing. They tried to move into devices with their Windows operating system. Google started with services, then they went to a platform, and then they moved into devices too. So, and Salesforce also moved from software as a service to a platform. So everybody is moving towards a platform. Infrastructure at this point, there's no way if you're a new entrant to try to play competitively against infrastructure players that have multiple billion-dollar infrastructure there. So for that, from that layer, new entrants would be very difficult. But everybody's moving towards platforms and figuring out how to figure out some way to get into this. Yeah, Apple too. It's gone. It looks a little bit like that. So the global players are headed towards the platforms. Everybody was headed towards platforms. Almost everybody lost. And so then platform players are then moving towards how to integrate into hardware. So then, and then commoditization of those who couldn't integrate with the platform. So then the question is, with the Internet of Things, if sensor networks on the edge of the networks produce so much data that there's not enough capacity for the networks to carry the data to the central data centers to be processed, then a lot of the processing happens still on the edge, where it says which is the important data to send and which is the ones to cut off, or let's do some analysis here and send the results of the analysis to the center. Is that, the big question is that a new architectural shift that will lead to new opportunities for new players? Because it went from internet being decentralized to cloud being very centralized, and now is it going to be more decentralized again? Or are the existing cloud players going to be able to figure out how to provide enough power in the platforms that the decentralized gathering of data can still be brought in? So how do you manage, and it does seem to be the pipes, the actual network capacity, that's the next bottleneck. That's the scarce resource here. So I paid you to ask that question so I could answer all of this. Anything else? Yeah.
This is a little bit vague question, but what do you think about the strength and the weakness of the Japanese firms in this era?
I paid you more because, so the question is, what's the position of Japanese players? And so here's a different analytical framework. Providers, layers, users, modality, and scope. And we don't need to explain this, but basically, it's a framework for analyzing global competition. If you look at the global US firms, Microsoft, Google, Amazon, IBM, HP, Salesforce, Rackforce, Twitter, Facebook, they actually have, these ones provide all three layers, cloud, network, device, right? Cloud, network, because Amazon and Google and Microsoft have been buying the network capacity. They've been buying fiber optic infrastructure so they don't have to pay someone else to do it, and they have more end-to-end control. They have these, and everybody has at least some kind of platform offering. The users are consumers and firms, and let's not worry about the modality, but their scope is all global. So this is the US firms that are global. They're all doing this. Let's look at the Japanese firms. major IT vendors of NEC, Fujitsu, NTT Data, Japan's telecom carriers, NTT, KDDI, SoftBank, Japan's consumer electronic firms, Panasonic, Sharp, Sony. Hopefully they'll be still around in a bit. Rakuten, Yahoo, Japan, and Gree and Mixi. So Asakura-san just left. So the point here is that they are all provided. They don't. This looks very different, right? Their scope is all local. They're not going toward. They don't have platforms offerings. They are limited in their layers that they're interested in, and a lot of them are. Well, they're tied to firms in many ways. So there's a huge difference between the global-facing, fundamental core infrastructure type offerings by the U.S. carriers and then the Japanese ones. And the major challenge for Japanese large firms is that they're longtime customers of Japanese IT vendors. And so I was trying to figure out when I sent a PowerPoint presentation to one of the preeminent Japanese IT firms, and it was 6 megabytes, and it came back because you can't send anything more than 5 megabytes to them. This is very typical, right? If you work in a Japanese organization. So then you receive a link to an external site that says, okay, this and that, or different multiple emails with this or that. Well, the question is, so then I said, why is that? And then first somebody said, oh, it's probably a security thing. No, dangerous files are usually very small. It shouldn't be a size requirement. And in an era of abundance, why can you not send a 6 megabyte? We've been doing that here for maybe at least since the late 1990s. Right? So is it a capacity issue? If it's a capacity issue, how in the world is your data center configured so that you can't do that because it's a decrease of productivity? And if that's the issue for just a PowerPoint, what about much bigger data sets that you would like not to split up and experiment with? So then the question is, why are the companies using the IT vendors that can't provide better service? Well, it's because they're locked into customized solutions. So one of the things that our co-author, Jonathan Murray, did in Warner Music was to completely redo the IT system from proprietary legacy systems that are connected together, and it's a patchwork. This should sound familiar if you're in a big company, patchwork of different systems that are just being held together. So just completely wiping it away, putting in a new platform where you can swap in and out infrastructure or databases or anything like that. Everything's controlled in the platform layer. And you provide building blocks, sort of like Lego blocks, where you can provide non-specialists tools to provide functionality that they think they need. Well, there's a data source over there being generated by customers doing this and that. Here's a different data source by how our suppliers are doing this or that. Why can't I, as a non-core computer scientist person, say, okay, there's that output stream, here's this output stream, click, click, drag them together, and then have them talk to each other, and then do this analysis to it, and then have that. Oh, which tools do I use? Oh, well, here's an analytical tool over here that's useful for that. Why can't you do that? Because right now, this system only talks in this way to this set of people. This system only talks to this set of systems, and data is encoded in a different way. And you can't physically bring them together because they're not connected. That one's in Europe. And this happens way too much in large companies. But if that's, now we're at the cusp of that being all swept away with the new start from clean type of approach. If the competitive large firms start to do this, everybody that's not doing it is going to get left behind. It took 75 years for, and my favorite story is it takes 75 years for factories to make use of electrification, moving from steam power to electricity. It took them 75 years to increase productivity because first, the factories were set up with the steam engine in the middle. All the equipment was arranged around and connected with belts. And then when they got electrification, they said, okay, here's the electric motor. We're going to replace the steam engine with the electric motor, but the machines are all still located in the same place. And it took them a long time to figure out, actually, they don't need to be aligned with the logic of belts to the steam engine. You can be aligned in the logic of production. And so let's realign it. Massive productivity gains. This time around, it won't take 75 years, but there's a significant lag time in large organizations that are moving very slowly, and they're very complex to jettison a lot of the legacy systems and put in these platforms that will allow new data flows that can allow IT to be used as a strategic weapon. So, Those are great questions, and I had very long answers for them. So maybe we'll call it a day. And please do take a few minutes to get to know everybody else that's here. And if you don't get a chance, we'll send an email, because one of the things we're doing with the Stanford Silicon Valley New Japan project is building a database of people who show up to various events, and so that if there's somebody that's of interest to you, just what's on your name card, right? Name, where you are located and what you're interested in, how you'd like to be contacted, so you can network with each other later. A nice example, Japan's privacy regulation went too far, so you can't even share a database of spreadsheet of people who appeared at something like this, because people were worried that it would. Now that law has been relaxed a little bit, but at the same time, this is the kind of issue that we at Silicon Valley are good at getting around. So please do spend a little time to get to know each other. And we hope to see you at future events. Thank you very much.